Welcome to supplemental video number 2. So this video is going to cover logarithm identities, the unit circle, the Pythagorean identity, and inverse trigonometric functions. So logarithm identity, starting off with log with base n of m times n is equal to log with base a of m plus log with base a of n. And the proof for that is if you take a to the power of either of these, the result will be the same because of the rules of exponents. And then now log with base a of m to the power of n is equal to n times log with base a of m. This one is important. You're going to be using this a lot in calculus. So if you can't remember the previous one, then that's fine, but this one is important, so you should definitely remember it. And so you can use the previous one to prove this one. So log with base a of m to the power of n. So m to the power of n is just the same as m times itself n times. All right, and then now using the previous identity, you can split these into their individual logarithms and add them all up. So you have log with base a of m added n times. And now if you keep on, repeated addition is just multiplication. So this is equal to n times log with base a of m. All right, and now the unit circle. So this is the graph of x squared plus y squared equals 1. It is a circle with radius 1 centered at the origin, and it can be used to evaluate trigonometric functions. So if you draw a line with angle theta from the x-axis, you can determine that sine of theta equals the y value where this line intersects the circle, cosine of theta equals x, and tangent of theta equals y over x. And this is because sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And now the hypotenuse is equal to 1 because it's the radius of the circle. So the unit circle can be used to evaluate trigonometric functions with angles outside of the range 0 to 90 degrees or 0 to pi over 2 radians. So given that sine of pi over 6 radians is 1/2, what is sine of 5 pi over 6? So give this problem a try if you want. Okay, the answer is 1/2 because this is the angle pi over 6 and this is the angle 5 pi over 6, and you can see the sine is just the y value, and you can see they're both 0.5. So in fact, sine of pi minus theta equals sine of theta for any value of theta. All right, and now, so given that cosine of pi over 3 equals 1/2, what is cosine of 2 pi over 3? The answer is negative 1/2 because this is the angle pi over 3, this is the angle 2 pi over 3, and cosine is just the x values. So you can see that this value is positive and then this value is negative. So that's why cosine of 2 pi over 3 is negative. All right, so if you want, go ahead and pause the video and give these problems a try. All right, so the answer, sine of 0, is just the angle is 0, so you're just drawing a line along the x-axis, and then this point right over here, the y-coordinate is 0. Sine of pi over 2 is equal to 1 because the line is this line right over here. It has an angle of 90 degrees with the x-axis, and the y value is 1. Cosine of 0, that's this line right over here, and the x value of this point is 1. Tangent of pi over 2 is undefined because this line right over here, the y value is 1 and the x value is 0. So you have 1 divided by 0, which is undefined. All right, and then now we're going into inverse trigonometric functions. So there are two ways to write them out. either arc and then the function of x, or the function and then like this looks like an exponent -1 of x. But keep in mind that this is not actually an exponent. And the definition, so if arc cosine of x equals y, then x equals cosine of y. So basically it's the opposite of the trigonometric functions. So if you have cosine and arc cosine of x, then they will cancel each other out. All right, and inverse trigonometric functions need to have a range, because if there wasn't a range, then there would be infinitely many solutions to inverse trigonometric functions. For example, arc sine of 1 could be pi over 2, 2 pi plus pi over 2, and so on, because sine of pi over 2 equals 1. But if you go 2 pi radians or 360 degrees around the unit circle, you're going to get back to the same point. So sine of 2 pi plus pi over 2 is also equal to 1. And then the same is true if you keep on adding 2 pi. All right, so this is why we need a range. All right, and here are the ranges. So arc sine must be between negative pi over 2 and positive pi over 2. And the same is true for arc tangent, and arc cosine must be between 0 and pi. All right, and now here is another notation of trigonometric functions. So tangent to the power of n of x means tangent x to the power of n, except when n equals -1, because remember that tangent with -1 of x means arctangent of x. And the reason why you say it like this is because if you said tangent x to the power of n, it would be confusing. People would think that you mean tangent of parentheses x to the power of n close parentheses. So this is why you say the exponent first before saying x. All right, and remember these identities, they're pretty simple. So this one is the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1 for any value theta. And this is proved using the unit circle along with this one. Tangent of theta equals sine of theta over cosine of theta for any value of theta. All right, and that's it for this supplemental video. So now you're all ready to go ahead and watch video number 4.